This part of the presentation is going to focus on structural glass facade types, the structural systems that hold the glass panels in place. And Enclose had originally had a web page, and I've since lost the link to it, where they described the whole taxonomy of glazing systems, from mullion systems to truss to cable systems, glass fins, and we'll cover each one of these a little bit. And this idea of them going from like a mullion system, which would be at the bottom of the pile, so to speak, as far as cost goes, having the least amount of transparency, and some of the highest level of design flexibility. I think it is. Let's see if I can find it again. Constructability, maintenance, yeah. Design flexibility, there it is. I'm sorry. So to the top of the scale, that has systems like a cable mullion that has a very high amount of transparency, but also an associated amount of cost, and then surprisingly the least amount of design flexibility. So it's a complicated matrix. I don't expect you to really get it all in one pass, but I wanted to introduce some of the basic concepts. So mullion systems, they illustrate, and then they'll show you a photograph. And so here's, as they're describing a mullion system, the idea of these divided lights having a divider between them. And in this case, we talk about this idea of transparency. You'll notice in the receding part of the view how these fin systems start to block the transparency of the glass system. These vertical fins are probably aluminum or steel, I'm thinking aluminum extrusions, elegantly supported at the bottom in a pin connection, but they still take up vision and I guess detract from the feeling of transparency of the glazing systems. This is another mullion system that they feature, and we've already I've shown you in the previous presentation. This is a really beautiful facade system, and in all of these we're either going to be looking at vertical kinds of ways of carrying the loads of wind loads on the glass. Mostly what we're concerned about with a facade is the loading in the I guess the transverse direction, the wind loads that come upon the glazing system. So here we have a vertical support structure carrying transferring the load into the roof or the floor deck, and here we're transferring it into other structures which aren't actually visible in this case. There might be a connection here to this main steel column to this part of the grid system. But this is really beautiful. So we have a tubular system supporting the glazing system here. And this back rib is really just to add section properties to this to help it resist its bending. But it also has a beautiful visual effect in benefit to it. So we're moving towards this idea of more transparency in glass, and so the next thing we look at is this idea of truss systems, where we're now starting to open up the members just like a web truss would have instead of being a solid object. So here we have a nice view of a truss system. Once again, the loads are being carried from the ceiling plane to the floor plane, and the intent here is to resist wind loading on the glazing system. And you know, I kind of put both of these images together because to say one is one way and one is the other is kind of a little bit misleading. You'll notice that we do lack transparency here, but in this truss type system, you'll notice that there's a lot interfering with that feeling of transparency, and there's really a strong feeling of busyness about its detail, so to speak. So you know, the idea of just black and white on this is never really completely clear. And here's another example of that idea that of these truss systems, now just like the original mullion system, but now instead of that being a solid mass, they've opened it up. So they're kind of starting to bring back that feeling of transparency as you look through the members. We can then move to like systems that are cable supported. This is the start of moving into cable systems, where we have kind of a tensegrity thing going on. We've made trusses where the outside cables are tensioned in order to create a rigid mast-like structure. When we talk about a mast, we think about a mast like a boat or an antenna system, and this idea of these struts are to stiffen the slender center mast member through that cable tensioning. The thing that's really missing that makes this not look like a truss system are diagonal bracing. And the reason there's no diagonal bracing is because this member is continuously held in tension across its span. And so here we have a look at a mast system. This looks a little odd, but this is a glass ceiling up here. So now we have the tension cable, and then these outriggers are connecting to spiders which are supporting the glass system. And the idea here is to create a large amount of structural support, or a large wall, a great deal of vertical structural support of the glazing systems. And now we really get a chance in this image to see that idea of what it can mean as far as transparency goes. So we have a column system that's probably, in this case, I don't think it's actually supporting any roof loads, although it might be. I'm just trying to figure out what's going on here. It looks like we have truss systems. So this may be supporting both roof loads and also lateral loads from the glazing system. And we have some cable struts. Actually, these are the vertical ones, but we also have transverse ones, as you can see illustrated here, between each one. So this is really quite an elaborate set of cabling, but once again, a lot of transparency with it. And not the kind of busyness, because the cables are so small and thin, not the kind of busyness that comes with the truss systems that we've looked at. And then we get to this idea of a cable truss system. These are kind of, really already pretty much seems like the same thing to you, but you'll notice we no longer have a vertical mast, and our tension is from the idea that these are both rigid points at the top and bottom. And so here we have no mast now, so we're really moving towards a really transparent looking facade system. And so if we move away from cables now, and there's alternate problems with this. One is that the loads of putting tension into these cable systems have to be borne by the ceiling or the floor plane if there's no center column through here to take the tension loads. So that can add additional structural requirements. So here we have the next thing along that idea of the lines of transparency is really, now we have no cables or minimum cables. In this case we have some rods running transversely, but we have a vertical glass fin creating our structural member. And now in this view you can see that it's almost like there's nothing there. We're seeing the edges of the glazing systems and the silicone caulking between the glazing panels. These are called spiders. They're really clearly apparent right here, and it's really difficult in this view to actually see these spiders. There's a half of a spider on one side of the glass and a half of the spider on the other side of the glass. But a great feeling of transparency in these large, great glazing areas. And you might think, well, there's all this stuff in the way for my transparency, but these are massive amounts of glazing surfaces. Many times these are 5-6 feet across by 10 feet high. So these really become, in the field of view, very minimum type of elements. So here you can see a little close-up of that. So we have this glass fin, and I guess maybe I need to better explain what's going on here now. Instead of that cable system that would be running, or a web system, or even this being solid, this is a glass fin. And this is going back towards into the face into the building, and that's carrying the wind loads. And maybe a little different, this is actually not the same system because we're seeing a different kind of spider here, but we have the sheets of glass. The cable is supporting the back side of the fin. That's like a bracing system, just like a floor deck would have, where it has cross bracing. And obviously the attachment from one panel to the other with this connector system, and the one connector system then serves as the spider element for the panel attachments. And in this case, that I'm trying to point out here is this kind of cable that goes between those panels. So now, to get to probably some of the most high performance and complicated systems, the idea now of just making a mesh system, very thin cables under high tension to resist any lateral load, any wind load across the panel systems. The problem with these is that this is the visualization of this frame system. This needs to be building structure. It needs to be very strong because we're putting pressure or tension, excuse me, on these cable systems to make this a very taut surface. So to give you a feeling for that, in this first illustration, you can see that these are the cables that are coming down to pull that glass system tight. It's a little difficult to see, I think, how seamless this is because there's a lot of things going on through this view. But I wanted to pull this one up or kind of push on this one a little bit because of this idea of you can now visually see how they're putting tension in the cable. Typically these tension systems would be buried. You just see the cable coming through the floor deck and you wouldn't see any kind of tensioning system on it. Here they've decided to make that kind of that explicitly visible that there's tension in these cable systems. So we have this kind of a rocker arm with a spring that's creating the tension within this cable. And this spring is pushing outwards or pushing up, and on the other side that makes it pull down. And because this lever arm is longer and this one is shorter, this is actually putting a great deal of tension in the cable system because of leverage. And here's an external idea of that same manifestation of cable systems. And if you bury all of that, you can come up with systems that look like this, where you're actually just seeing large panels of glass with what appears to be nothing to structurally support them or keep them in place. And that's because these cables are running within the mullion grid, and they're going from floor to ceiling and from structure to structure. And in its most, I guess, extreme way, this is a really beautifully double curved system. The idea is the cables, obviously, just as you would pull a cable net of any form over certain shapes, there is a certain kind of conformance of that shape. So in this case, this is doubly curved, which means you can see that it's curving outward as we go up, and it's curving inward at the same time. And the idea is that these cables are, how can I say it, pushed out further at this point, pulled back here, but they all have the same amount of tension in them to create a rigid glass surface that has curvature to it. There's a huge cost to this kind of construction as far as the structures go, because we have to resist all the loads that are created by these cables and tension. And that's represented by the arrow up here that I'm showing you. Look at this massive truss. Look at the size of the individual members in here, all intended to resist that the forces of the cables being pulled over the top of it and separating the two elements of the top of the building components from the pressures of this cable system. And this is an extreme and really awesome, quite piece of work. So here we have SOM's cable system for almost an entire facade of a curtain wall of a high-rise. And then these are these massive cable systems and massive fittings to pull this tension in to the system. And this is an interior atrium space of a high-rise and the outside glass curtain wall, trying to be as minimum as possible with structure, but really beautiful fixturing and massive amounts of structure to accomplish that. And the final one here is cable mullion systems. And I'm not sure why they put this in the kind of order that they did, but here we have just hybrids of systems, I guess is the best way of thinking about it. So this vertical element here, which is a solid piece of steel. Notice the spider element supported here. These transverse cable systems. I find one of the things I find probably significant about this view is that most of the structural support couldn't be borne. These members aren't thick enough to support wind load. They're probably there to support just the cable system that's going transverse. But so most of the structural support is borne by this cable system, this transverse cable system, as far as bending goes to resist the wind loading. But by making it go in the horizontal direction, you'll notice what a clear vision glass we have here. Nothing interrupting it. You can imagine if there were repeatings of these as vertical, you'd be looking through a lot of those elements. So that wraps up our first part of our glass presentation, and for the next module we'll pick up on glass part 2.